Today we're going to look at solving logarithms. So we've looked at making logarithms into exponential and how they're actually an exponential equation. So since we know how to put them in exponential form, now we're going to actually solve for a variable. So not always will our variable I be at the end. And that's what today's lesson is going to be over. So I'm going to go past these. So our goal today is that you can say I can solve logarithmic equations. This is still goal 2, just kind of extending that out. So now we're going to have an equation. So we're going to have an equal sign already in there. So here's our first one. We know that we can write, so notice before today our x was here. Now we're going to have x's in different locations. So we'd rewrite it in exponential form. That's always going to be step 1 when it's if that's all that we can do, unless we can cancel out, which we'll talk about later. So I'm going to write 8. So it starts at your base, pick up your exponent, and ends at x. So x 8 to the 4 thirds equals x. And then we can go ahead and solve 8 to the 4 thirds. We can rewrite 8 as 2 to the third. And when we have a power to a power, we can multiply that. So that equals 2 to the 3 times 4 thirds, which would be 4. And 2 to the 4 is 16. So we're going to pull back in some of those radicals that we did last unit. Another example of solving it with no variables here, we could do 27 to the 2 thirds equals n, and really you could probably put that even in your calculator, but we can rewrite 27 as 3 cubed. When we multiply 3 times 2 thirds, 6 thirds, or 3 squared, which equals 9. So you want to go ahead when we're solving, have a whole, or have a number, not a whole number necessarily, but have a number answer. We shouldn't have powers and so forth, or variables. Alright, so here's one of the first property we're going to talk about. So if I have log the same base on both sides, so we see that right here, if the bases and the logs equal, then the what it's a log of is also equal, so then x equals 8. So here, since the log base 4 and log base 4 are equal, then x squared equals negative 6x minus 8. And then we're going to use our different things that we've learned on how to solve that. So I can add the 6x and the 8 over. So I'd have x squared plus 6x plus 8 equals 0. And then we can factor that. What multiplies to be 8 adds to be 6, 2, and 4. So x plus 2, x plus 4 multiplies to be 8, adds to be 6. If I put those equal to 0, it would be negative 2 and negative 4. We can't have log of negative, so we would want to make sure, like here, if I plug in these negatives, I get squared. If I plug in these here, this becomes positive, so I won't have any negatives left over. So that would be our two answers, negative 2 and negative 4. All right, let's look at another one here. We're going to move past that one. Same thing with inequalities, that I can rewrite it as an inequality, so I can do the same as I did with exponential functions, b to the y. Here, x is greater than, so notice this is a little bit different. So we would write that equal sign at the end, but b to the y, x equal is greater than b to the y. So I could rewrite this as x is greater than 6 cubed, and then figure out what 6 cubed is. So x is greater than 216. And then less than, x is less than 3 base 3 to that power. So x is less than 9. And it also has to be greater than 0 because this can't be negative. So that's why it's this one. And the same is true where if they have the logs of the same, then their inequalities is the same. So since these are both log 7, then 2x plus 8 is greater than x plus 5. Subtract x. X plus 8 is greater than x plus 5. Oh, I subtracted that, sorry. Is greater than 5. And then subtract 8 on both sides. X must be greater than negative 3. Answer. All right, let's look at, that's all that we have for solving logarithms, equations, and inequalities.